The first step of muscle contraction is excitation. The action potential is sent through the neuron and arrives at the synapse. This allows the calcium-gated channels to open, which allows the calcium ions to come into the axon terminal. The calcium goes to the vesicle that contains acetylcholine. The vesicles fuse to the membrane and go through exocytosis and release the acetylcholine into the synaptic cleft. In the synaptic cleft, acetylcholine binds to their receptors on the motor end plate.
The second step of excitation is contraction and coupling. Binding opens the gate channels, which allows sodium in and potassium out. That leads to another action potential that is sent across the sarcolemma and down the T-tubules. This action potential opens the calcium-gated channels and calcium is released from the terminal cisternae.
This is the third step of contraction. The calcium then binds to the troponin, which is on the thin actin filaments. This causes the troponin to shift, which uncovers the active sites. The myosin heads bind to the active sites and form a cross bridge. The ADP and P are released from the myosin head, which cause a release in energy that can move the myosin head towards the M line. This moves the entire thin filament. Another ATP binds to the myosin head and breaks the connection between the myosin head and the active site on the actin. The myosin head breaks the ATP into ADP and P. The energy is released from this action and is used to recock the heads back into its original position.
The fourth step is relaxation. When there is no longer stimulation, contraction processes discontinue. Discontinuing stimulus stops the release of acetylcholine. Acetylcholine is broken down by the acetylcholine enzyme. Calcium is reabsorbed into the sarcoplasmic reticulum. Calcium ions are no longer bound to the troponin, so the tropomyosin moves back to cover the active sites. Myofilaments cease to move, the fiber relaxes, so does the muscle.
The regulatory proteins that were used in this process were tropomyosin and troponin, and calcium. The contractile proteins are myosin and actin. If a person has just performed some warming up exercises, it allows the muscle to perform at optimal strength. If a person is experiencing heat stroke, it is causing the functions within the body to not work properly. It would degrade proteins, which would make strength go down and fatigue the muscles.